All right, so we're going to build a automatic speech recognition application or audio to text transcription using Whisper. This is a model from OpenAI. The one that we're using is actually built on top of Whisper from OpenAI, but it is running for free inside of the browser using a library called Transformers, or using a technology called Transformers that runs locally inside the browser using web workers. So you hand off the process to a web worker that runs in the background in parallel with your own thread. So it's not running on the main thread, so it doesn't block your app while it's loading or while it's transcribing, which is an exciting concept for our front-end applications if you're running models or if you want to add AI features to them. We have talked about Transformers in the past. I will link a video in the description where I talked about them more in the Hugging Face platform and how you would go about using them. In that video, we built an object detection application using Transformers again. If you want to brush up on what they are and how to use them, you can kind of refer to that video. I will explain from a high level what they are and how you would go about them, and mention the documentation throughout the process of this video as well. And we're going to build this app from the scratch together. So if you haven't worked with the Hugging Face platform or the Transformers, this may be a good start. Let me show you what we're building, and then we're going to dive into the code after we talk about Hugging Face and the specific model that we're using. So as you can see here, I have a left card that allows me to pick an audio file from a URL or record one internally using my system. On the right-hand side, we have the transcription, and then we have some progress bar for detecting if the model is loaded or not. Now, the way that service workers or we have set up this to work is once you load the models the first time, you don't have to reload them every time. So it just gets cached inside of your browser. And then on the subsequent interaction with the model, it just loads the model from the cache. So it's pretty fast the first time it loads the model. It may take a little bit of time. That's not even long, but a bit of time. But subsequent interactions would be from the cache. So let's actually see how it works. So I'm going to go ahead and hit record. So if you're recording, test 1, 2, 3. This is a recording using the Whisper AI model. We want to transcribe the audio file to English. Now, it shows you an audio player. I don't know if you hear it or not, but you can listen to your recording, and if you liked it, you could just load it where it just loads it in or makes it ready for us to actually transcribe. So once I hit the transcribe, it checks to see if I have the model. Because I have the model, it used the cached version, so it was very fast, and then it actually went ahead and transcribed this. Now you can reset it and do it from a URL and whatnot. So that's the idea of this app. Now let's talk about the model very quickly, because it's not only for transcription. You can also use it for translation as well. So we've talked about Hugging Face. You can think of it as the GitHub for different open source models. And this is an open source model that I'm using here. Now, to find different models, you can just go to the models and select the tasks that you want to do. For example, object detection, text to image, image to image. In this case, we are working with automatic speech recognition. Now, there are different libraries that you can that may or may not work with these models. So we can go on the libraries. In this case, we are working with Transformers.js, which is a JavaScript version of Transformers in Python that allows you to run a pipeline of this for any of these models with some pre and post processing, and then basically navigating the data or your input through this pipeline to get your output through that model. So the one that we're using is Whisper Tiny. Now, Whisper, which I mentioned, it's based on the OpenAI Whisper Tiny, It does a couple of different things. So one of which is speech recognition. You could use it. It's multilingual, so you can use it for different languages other than English, and you can use it for translation. So the application of what you can do with this is really more than just a transcription. So you can just dive deeper into what this does if you were interested. So I'm going to go back. We're going to be working on this, and it's pretty simple. You're going to use a pipeline from from your Transcriber.js library, and we're going to just create the transcriber out of that pipeline, and then pass a URL or pass an audio file, and then you can have it return the text. You can have it return the timestamps. You can have it return timestamps at a word level by passing in different options. So I'm not going to get into the details. We're going to look at a high-level implementation of this inside of Next.js. Now, before I go ahead, I want to also mention that in the documentation working with Transformer.js, which I reviewed in the first video that I mentioned, there are good examples of how to actually use this library, but there's also tutorials for implementing Transformer.js in Next.js app. We've covered this again in that video. There's some stuff that you need to do for Next.js, specifically the way that Webpack is bundling your application that you have to pay attention to. And then there is also an example application, React application building on Whisper. The app that I have built is inspired by that app. So I want to give a shout out to that. So if we go to, let me see if I can find that. Yeah, so I will link this in the description as well. So there is a live version of this same app that we're building. It has more features in that you can pick different languages and whatnot. For us, it's, again, a simple implementation of the Whisper model and English transcription. But once you get this done, you can implement any other functionality that you want on top of that. So I have my Next.js application on the page, on the main page. I have two really important pieces of our app. The audio manager is what we see here. And the transcription, this component, which literally gets the output of our transcription and shows it on that card, is this one. So let's start from the audio manager. Before I get there, actually, let's talk about our transcriber and how we're using it. So I have this hook, use transcriber. So let's dive into this and see what is this doing. Now, this mainly manages some state in what is happening with our transcriber pipeline. So is it processing or not? Is the model loading or not? Do we have any output or not? So we are holding some states and sharing them via this use transcriber hook. Now, inside of this use transcriber hook that we are sharing, you can see different functions and functionalities shared through this hook. What's important is this use worker hook. So I'm using another hook, and these are React-specific or techniques, concepts in sharing the functionality within React. You don't have to do it like this, but I think it's cleaner, and it is also inspired from the repo that I mentioned. So the use worker, let's see what this does. This passes an event handler to the worker that we're going to create. I'm going to show you how we're going to create that, but then basically attaches this event handler to our worker. And this event handler checks the status of our event when you are handing off some tasks to your web workers. The way that they communicate between the worker and the main thread is through this messaging system. So it emits different events based on progress, update, complete, initiate, ready, error, and whatnot. And we are setting some state depending on what's happening on the worker. And then, for example, in the complete, when our task is done, we are emitting this event with the status of complete. We are passing the data back to the main thread, and we are just literally setting a React state to get that output and then show it in our transcription card. Okay, now how do we go about creating the worker itself? So let's dive into the use worker. Now this is again another hook, and what it does is it's a hook that creates a worker once and never again, because we're passing in a function to our user state webhook or hook. And inside that function, we're calling this function that says create worker, and it accepts a message event handler. Now in the create worker function down here defined, what we're doing is we only make sure that this is running on the client, because we need to get access to the workers in Next.js, because this code also runs on the server. Even if it's a client component, you have to make sure that to eliminate any discrepancies between the server and the client, we only run this, or we only return this if it is running on the client, and we're defining that by just checking the type of window. Now we're going to create a new worker, and the way that you create a new worker is that you pass in the URL or the path to where it lives. So it is living inside of our lib worker.js. So we create that worker, and I'm attaching an event listener to it, passing the same function that was passed to this hook. So that's what we're doing here. Inside of this use transcriber, we're calling this use worker, we're passing this event handler, and now this is going to be attached to our worker. So therefore, anytime that our worker that's defined in worker.js actually sends a message, we are capturing that and responding or handling that event with the same event handler that I just showed. Now, how do we create a worker? Well, here we're using a singleton pattern to make sure that we only create this worker once. So we have a pipeline factory. And what we're doing here is that we have a static or a private function here that gets a process callback. And if the pipeline doesn't exist, it is going to create a pipeline. This is what we get out of this package. So we create a pipeline from the task model with a process callback. Now the process callback is for when the model is loading for the first time, it emits some events, and that's how we're tracking the progress of model being loaded. Now I'll show you how it works. Let me actually show you now. So if I go inspect, let me just make this a bit bigger. So if I go to my application and cache storage, you can see all of these models that have been cached. So if I delete all of them, so we're going to go ahead and load them again from scratch. So let's refresh this. And now let's say if I select this URL, and now I want to transcribe this one, you can see it goes ahead and loads the model first. And that progress is what's happening through this progress callback. So it sends the process callback back to our own event handler. And inside of our event handler, when we're receiving a progress message, we are just setting this state that tracks and then shows that inside that bar. So that's what we're doing there. So that's how you would create a pipeline, and that you can see inside the documentation. So you pass the task. In this case, our task is automatic speech recognition, and the specific model we're using is this model. You just copy the name from Hugging Face, and that's how you create your pipeline. Now here, the pattern that we're using is that we have one main class, and then we're extending this class by a more specific one, which is for automatic speech recognition. So this extends our pipeline factory, sets this task to speech recognition and the specific model. Now we also have this event handler. So we attach an event handler so that when we're actually going ahead and transcribing what is passed to us. So this is to say, hey, web worker, if you receive the message, this is what I want you to do. Get the audio from the message. This is what we are getting in the front end. And when we want to hand this off to the web worker, we're going to emit an event to the web worker and pass the audio with it. And inside of our worker, we're listening for this event. We're going to get the audio, and we're going to pass it to the transcribe function that we have down here. I'll explain what it is. But this basically transcribes the audio file. And if we have the transcription, we're going to post a message back to the main thread with the status of complete. That's why we had this complete here. So we are basically communicating between the two threads with this messaging service. So once it is completed, we pass the data as well, and then we show the transcription in the client side. Now this transcribe function literally uses the classes that we found or we created to get an instance of our pipeline that has been defined here specifically for speech recognition. Once we have the transcriber function, we pass the audio file that was passed to the web worker via this message. And some options. If your audio is longer than 30 seconds, I guess, you have to chunk it up. And this is how you would chunk it up. And you can define some overlap between the chunks. So I'm passing in some options as well, catching any errors. And in case of any errors, I'm posting a message with the error and then passing the error. So you can also handle errors here. Right now, I'm just setting the processing state to false, and I'm not doing anything else, but you can handle it however you want. They're different. Basically, you can emit different message events or messages between the two threads. And if I have the output without any errors, I'm just returning the output. So this is a transcribe function we were calling up top here. When we receive the message from the main thread inside of our worker with some audio file, we went ahead and transcribed it and returned the audio. This returned audio is now posted back to the main thread using a messaging system. Now, if you've never worked with web workers before, this might be confusing to understand who's sending the message to who, but just imagine there's two threads talking and communicating with each other. They both receive these messages. We create one using workers. The other one is our own main thread. We receive the audio in the front end or client side app. We pass this audio through a message to the worker. The worker calls the transcribe function, runs the model in the background, so we're not blocking the main thread. Once it's done, it sends a message back to the main thread with the data to say, this is your transcription. Then the React components are going to show the transcription. So this is from a high level what's happening back there. All right, so with this out of the way, let's just go back to our pages. So we are now getting this transcribe. Again, this transcriber is just exposing some functions on input change, which is basically this states that we're holding here. Is processing, model is loading, start and output. Now the output is when the worker actually responds back with the output of our transcription. I've defined also a start function. Now this is start function is how we're calling the web worker or how we're passing in a message back to the web worker. So how are we doing it? Well, we're going to receive an audio data. So we're exposing a start function to our client-side application, to our React application to say anytime that the user chose an audio or recorded an audio and decided to transcribe, you're going to call this a start function, which is going to take that audio file and it's going to this is going to get the channel data. So if it's a stereo or mono, it's going to get the channel data here, right? And then at the end, what it is doing is calling the web worker, posting a message to it with that audio file. This is all this start function is doing from a high level. It takes the audio file from the React side, calls the web worker, posts a message to the web worker actually, and the web worker is coming in from our use worker. So that's how we're getting a handle of our web worker, and we're posting a message to it with the audio. Now, whatever you pass to this post message is going to be available to you on the web worker. So if you go back to the use web worker here, actually to the worker.js, you can see when we receive a message, we have this event.data, and event.data is that same object that you pass to it. So now you can see there is this audio on it because what we did in the start function is we passed this object with the audio. So whatever you passed here, that object is going to be accessible inside of your worker through the event.data. And the same way when you're passing a message or event from the worker to the main thread, you can pass literally any object, and that object is going to be available on the event.data on the client side as well. So we have our transcriber and all the functions that we wanted to expose from start to output and to the states. And we're passing this transcriber down to these two components. One, to get the data and then post this message, and the other one to show the output. So let's go to the audio manager and see what we're doing here. So in the audio manager, we have two really important files, or in this case, dialogues, because these are SHA-CN dialogues, and these are the triggers for them because they open up the dialogue to different things that we can do with processing the audio. Now, let's start from the URL dialog. This is just a SHA-CN dialog again with a trigger. Now, inside of it, there is an input that you can paste in your URL. Now, it defaults to a hosted TED Talk, 1 minute TED Talk audio that you could use as a test, but you can literally post and paste the URL of any audio file. Now, once we have that URL, just you can see here, we can click on the load button, and the load button is going to call this onload function that we've defined here. The onload function is going to set or call the onURL change, which is passed to this trigger, and then basically close the dialog. So now let's see what's this onURL change. Inside the audio manager, where we were actually rendering this component, we pass this onURL change function. Now, onURL change function, anytime that the URL that the user pasted in there and then hit load changes, we're going to call transcriber that dot on input change. Now, this function just wipes everything out, informs the React that we just delete everything. We are dealing with a new file with a new audio here, sets the audio data, which is a local state here, and then sets the URL. So we're tracking the audio data inside of this audio manager and the URL. Up until this point, we hit load, we have the audio, we're not yet transcribing. We're just setting the audio data. Now I have the audio data, therefore I'm showing this audio player, and I can go ahead and transcribe. Okay, so that's where this transcribe function is. So we are rendering the audio player down here if I have the audio data, which is set whenever you paste in a new URL and hit the load button. And then I have a button that says transcribe. Now, if I go ahead and wanted to transcribe, it calls transcriber.start. That's the same function we looked at it together a few minutes ago, and passes the audio data.buffer to this start function, which in turn is going to, first of all, see if it's a mono or stereo, and then it's going to just post the message to the worker, receives this audio, transcribes it, and then we're listening for events coming back when it is ready. So that's basically what's happening here. I'm using the states that is coming back from the transcriber, such as when the model is loading, when it is processing. This is actually when a transcription is happening, to show different loaders and loading state inside of my button. So if you look at this button right now, it goes into a loading state with the spinners or with loaders while the transcription is happening inside of the web worker. So that was the transcription. Now, the second thing is a very similar thing, but for our audio recorder dialog. So again, a similar SHA-CN dialog, but this time instead of having an input with a URL or a hosted audio file, we have an audio recorder. So inside of this dialog, I'm just rendering this audio recorder. Now let's see what this audio recorder is. Again, this is using the Navigator Media Devices Get User Media. That's how you can record the user audio from their machine. There are different states and different refs that we're holding here. Now let's start from the states recording, if we are recording or not, if you're paused or not, and the recording time. And then we have some refs. Now we are holding a reference to our media recorder, to our audio chunks, which are going to use to then process or create the blob that we need to send back to our audio manager to send it to the transcriber function. We have the stream ref, so you have to create a stream and then pass that to your media recorder. We're going to see this in action. And a timer ref, which is going to be the reference of the interval that we set to just increase the timer. As you can see, when we hit record here, so if I reset and hit record, that timer is actually tracking the time. And we're holding a reference to this interval so that we can clear it out once we're done. You can also pause it and resume it all throughout these functions that we have over here. So let's see the functions. The first one is start recording. So as I mentioned, we create a stream using the navigated media devices that get user media, pass the audio through. We're holding a reference to it. Then we create a new media recorder from that stream. Again, hold references to it and empty the chunks that we have to an empty array. And we want to listen to two different events on our media recorder. One is when the data is available. Two is when we stop. When data is available, we're going to just push the event.data to our chunks. So we are holding a reference for our audio chunks, which is an array of this buffers or audio event data, which we're going to use to create our blob. And the second thing is on stop, when the user actually stops recording, we want to create a new blob from our audio chunks in a type wave format, and then we're going to call the onRecording complete and pass this audio blob to it. Now let's see what this onRecording complete is. This is a function that we have passed in to our audio recorder. So let's go to where we are passing this onRecording complete. Again, this is calling the handle audio recorded. The handle audio recorded is going to take that blob that we passed to it, set the audio file, set the audio data state here inside of our dialog. We could have passed in the set audio blob that we have here down and use it here, but we haven't. We are holding this state here as well. Again, we are creating an object URL so that we can show it in our media player, in audio player, and then we are setting the audio URL, right? That's what we're doing. Now, the reason why I'm holding this on top of that is that, once you record, you have this audio here. Maybe you don't want to hit load and load it there yet. Maybe you want to re-record it after you recorded it, or you didn't like it. So that's why I'm holding an interim state here with this handle recording that holds the audio data. And I'm going to only pass it back to our main audio manager to be ready for transcription if you hit this load button here. And on load here, again, we have a button here that calls handle load. In the handle load, if we have the audio data locally here, we're going to pass the onload function that's passed to us. We're going to look at that in a second. But basically, we're going to revoke the object URL. This is to avoid memory leaks when you're creating object URLs, and basically wiping out everything that we had in this specific component. Now, this onload is a function that we have passed in from here. So audio recorder dialog, onload, get the data, which is a blob, and then call the transcriber.onInput change because it's a new data. So we wipe everything out. And then we set audio from recording and we'll pass that data to it. This set audio from recording is a similar function that we have over here. This gets the data, creates a URL, a file reader, decodes it, and then sets the audio data. This is a local state that we have here. And once it creates this file reader with this event listener attached to it, we then call that to read this blob as an array buffer to that file reader. So whenever this is done, then we have the audio set. Now, once the audio is set, again, same thing. The user can go ahead and hit the transcribe button that just takes that audio data, calls the start function, and passes it to the web worker to be transcribed. So basically, the main two functions that we have here is setting audio from recording, which basically reads the file and set the audio data through this function, or the download audio from URL. Once we just pass in a URL, it again does a similar thing of processing the data and then setting the audio data from that URL. So it downloads the URL, it processes it as a blob and sets it as an array buffer to our audio data, which then in turn, if you click the transcribe, it's going to be passed back to our web worker to be transcribed. So this is from a high level what we're doing here. I don't think there is anything else much to explain here. The progress bar was just reading the state from Transcriber to show the progress of the models. We have the audio manager where everything happens. We either paste in a URL or record an audio and then transcribe it using Transformers.js, which runs using a web worker in the browsers. Now, if you want to expand on what we did here, for example, if you want to have translation as part of your transcription, so you say something in English, but you want to translate it into something else, or you want to transcribe from a different language than English, it's possible. I encourage you to look at the link that I have to the repository for the project that I showed earlier. It's not here. So definitely look at that with examples of how you would implement that in React. But basically, it's just a matter of passing in different options to this transcriber function or to your pipeline that's running on Transformer.js, and then having those options or selectors or forms in your client side so the user can select what they want to do, and then you pass those options depending on what they chose to your pipeline. If you have any questions, like always, hit me up in the comments. I'm planning to have more AI-related content soon. So if there's anything specific that you want me to cover, let me know down in the comments. I'm always looking for ideas, but you will see more content, AI-related content from me in future. And I'll see you in the next one. Bye-bye.